From majestic ships gliding across oceans to sleek airplanes soaring through skies, physics governs it all. These marvels, and even the mundane like dimming light through tinted glass, are testaments to the elegant laws of our universe. Join me, Tinkleton, as we unravel the mysteries behind these phenomena, exploring principles of Archimedes, Bernoulli, Beer-Lambert and Pascal. What makes objects float? Archimedes, a brilliant mind from ancient Greece, unveiled the secret. Archimedes' principle states that any object submerged in a fluid experiences an upward force equal to the weight of the fluid it displaces. Imagine a bathtub filled to the brim. Place a toy boat in the water level rises, spilling over the edge. The volume of this spilled water equals the volume of the boat submerged. This principle explains why massive ships can float. A ship's hull displaces a huge volume of water, creating a buoyant force greater than the ship's weight. Think about a cargo ship being loaded. As more cargo is added, the ship sinks lower, displacing more water to counterbalance the weight. This balance between weight and buoyancy is key to maritime navigation. Archimedes' principle governs the buoyancy of everything from rubber duckies to massive icebergs. It's a fundamental law that keeps our ships afloat. From the Wright brothers to modern jets, flight has captivated humans. The magic lies in Bernoulli's principle. Bernoulli's principle states that as the speed of a fluid increases, its pressure decreases. This principle is at the heart of how airplanes achieve lift. Imagine an airplane wing slicing through the air. The wing's shape, called an airfoil, is crucial. The curved upper surface forces air to travel a longer distance, increasing its speed and creating lower pressure above the wing. Meanwhile, slower air below the wing creates higher pressure. This pressure difference generates lift. Hold a piece of paper horizontally and blow over the top. The paper rises due to the low-pressure air above it. Bernoulli's principle shapes the trajectories of airplanes, kites, and even curveballs in baseball. It's the invisible hand behind flight. A light, that ethereal phenomenon, holds countless secrets. The Beer-Lambert Law reveals how light interacts with matter. This law explains why the world appears dimmer through sunglasses and how scientists determine the composition of distant stars. The Beer-Lambert Law states that the amount of light absorbed by a material is proportional to the concentration of the absorbing substance and the path length. Think about sunglasses. The lenses contain pigments that absorb light. The darker the tint, the more light is absorbed. In chemistry, this law is used in spectrophotometry. By shining light through a solution and measuring absorption, scientists determine the concentration of substances. For example, a chemist analyzing a blood sample can measure absorbance to determine levels of hemoglobin or glucose. This principle also allows us to study distant stars. By analyzing the spectrum of light emitted by a star, astronomers identify elements in its atmosphere. The Beer-Lambert Law illuminates the hidden world of light absorption. It's a powerful tool in both everyday life and scientific research. From sunglasses to stargazing, this law helps us understand the universe. How do hydraulic systems lift heavy objects with minimal effort? Pascal's law, discovered by Blaise Pascal, explains it. Pascal's law states that when pressure is applied to a confined fluid, the change in pressure is transmitted equally throughout the fluid. Imagine a hydraulic system, two cylinders connected by a tube filled with fluid. Applying a small force to the smaller piston creates pressure transmitted to the larger piston. This increased pressure acts on the larger piston, resulting in a much larger force. This principle allows a hydraulic car jack to lift a heavy car. Hydraulic brakes work similarly, transmitting pressure from the brake pedal to the brake cylinders at the wheels. Pascal's law amplifies our power, enabling engineering marvels. From excavators to airplanes, this principle is the silent force behind many machines. We've journeyed through physics, from buoyancy to lift-light absorption and hydraulics, scratching the surface of the wonders around us. Each principle, discovered by brilliant minds, unlocks a deeper understanding of the universe. When you see a boat float, think of Archimedes. When you marvel at an airplane, think of Bernoulli. When you wear sunglasses, recall the Beer-Lambert Law. When you see a hydraulic system, thank Pascal. These principles explain everyday phenomena. Share this video and let others explore the wonders of physics. Subscribe for more exciting science content.